Hey, what's going on, guys? In this video we are going to take a look at number system. I have done a few videos on that as well, but here I'm going to do it again, like from starting. First we are going to see how to convert a number from binary to decimal. And we have to know, whenever we have binary mean base 2, decimal mean base 10. So we will always have one less number than whatever the base is. Like for decimal, the maximum number we can have is 9. Because the base is 10, so we cannot go up to 10, like 9 is the last one. And for binary, base is 2, so we cannot go to 2, like 0 and 1 are the base, 0 and 1 are the numbers that's going to be in the binary. Now let's look at an example. Let's say we have a number like 101, excuse me, okay, 101.11, the base is 2, and we want to convert this one into decimal. Now let's see how to do that. First of all, I write the number again, 101.11, and we have to know what numbers are taking what places. And before we have the decimal point, we have to know it always start with 0. 2 power 0 taking this place, and that is 1 right here, and 2 power 0 is 1. And this one is taking the place of 2 power 1, that is 2, and this one is taking the place of 2 power 2, that is 4. So what happens after the decimal point? Decimal point, we go the opposite, like 2 power negative 1, this decrease. 2 power negative 1, that is half, and this one is 2 power negative 2, that is 1 over 4. Okay, now we can just if we multiply them, we will get this decimal point. So 1 times okay, first where do we start? Let's start from here to here. Okay, 1 times 4, 1 times 4 plus 0 times 2 plus 1 times 1, 1 times 1 plus 1 times half, 1 times half plus this one is 1 times 1 over 4, 1 times 1 over 4. So 1 times 4 is 4, and then 0 times 2, that is 0. We can neglect this one. This one is gone. And 1 times 1 is 1 plus 1, and 1 times half is just half, and 1 times 1 over 4 is 1 over 4. Now 4 plus 1, that is 5, and here we can take the common denominator as 4, so this is going to become 2 plus 1, 3 over 4. So we are going to have 3 over 4. That is basically 5.75. That's a conversion of this given binary number to decimal. So here the number is going to be 5.75, and that's going to be the answer. Now we are going to see another thing, how to convert a number from decimal to binary. To do that, I get rid of this one first. Decimal to binary, I write that one. So decimal to binary. To convert decimal to binary, now let's look at a number. Let's say we have 59, the base is 10. How can we convert this number from decimal to binary? Binary base is 2. Now to convert this one, what we have to do is we have to just divide this one until we get 0. So divide this one by 2 until we get 0. 59 divided by 2, that's going to be 29, and also we are going to have remainder of 1, and 29 divided by 2, that's going to be 14, and also we are going to have another remainder, and 14 divided by 2, that's going to give us 7, and there's no remainder, and then 7 divided by 2, we are going to have 3, and we have a remainder 1, and 3 divided by 2, we are going to have 1 and a remainder of 1, and 1 divided by 2, we are going to have 0, and the remainder of 1. And once we get 0 here, we stop it right there. When we get 0 right here, okay, we stop it right there. And what are we gonna do is we are gonna go the number from bottom to top. That's gonna be our binary number, 111,011. That's the conversion of this given decimal number to binary. Now let's look at a number with decimal points. Now let's say they are giving a decimal number. They are giving a decimal number like this. Let's say they are giving a number like 21.75. The base is 10, and we want to convert this one into binary. Now to do that, again, here what we have to do is we just have to do the complete the fraction part alone and the part without fraction alone. So we take the complete number first, that is 21, and we do the same thing like this. Divide this one by 2, and we will get 10 and a remainder of 1, and then 10 divided by 2, we will get 5 and a remainder of 0, and then 5 divided by 2, we will get 2 and a remainder of 1, and 2 divided by 2, we will get 1 and a remainder of 0, and 1 divided by 2, we will get 0 and a remainder of 1. Once we get 0 right here, we stop there and go from bottom to top. That is 10101. That's going to be the part before the fraction point. Now what to do for the fraction point? For fraction point, what you have to do is we have to multiply this one by 2 until we get 0. Like let's look at the next. Let's see this. 2 times 0.75. We are going to get 1.5. So I write 1 right here, and then the fraction part I separately write like 0.5. And then we have 0.5 again fraction. We multiply this one by 2. 0.5. That's going to be 1. And then we don't have any fraction point. That's 0. So once we get 0 for this one here, we stop there. And for this one, if you look at this, for this one we go from bottom to top. For this one we go from top to bottom. The previous number, the whole number is the one we count. So this is just 1 here. Okay, and that's the conversion for this one from decimal to binary. Now here we are lucky, we got 0. Sometime we are not going to get 0, but like we are going to have fraction point going on and on and on and on. Now let's look at an example like that. What to do in those kind of situations. Now I get rid of this part. And I'm gonna write a question like that. Let's say we have a question like this: 6.28 and the base is 10, and we want to convert this one into binary. Now again, for the whole number we do as this. We divide this one by 2 until we get 0. 6 divided by 2, that's 3, remainder of 0. And then 3 divided by 2, we will get 1 and the remainder of 1. And then 1 divided by 2, we will get 0 and a remainder of 1. When we get 0 right here, we stop right there, going from bottom to top. That is 110. Now what happens after the decimal point? What we have to do is we have to do again like we did before. We multiply that one by 2. First we have 0.28, multiply this one by 2, we will get 0.56. So I put 0 here, and then fraction point alone, 0.56, and then 0.56 multiplied by 2. 0.56 multiplied by 2 is 1.12. So we put 1, the whole number, and then 0.12, and then 0.12 times 2, we will get 0.24, 0 here and 0.24 here, and then 0.24 times 2, this is 0.48, 0.48. now you can keep on going like this. The next one will be 0.96, and then 0.96 times 2, then you will get 1.9 or something like that. So you will keep on going with this decimal point. You will never end up getting 0. That's how I chose a number. Sometimes you will be lucky, you will get 0. For this one you will not get 0. So it will be extending forever. So depending on the machine they are asking, like if they ask for 8 digit, round it to 8 digit, you have to go up to 8 digit. If they just want 4 numbers, you can stop it at 4 number. If they want 16 digit machine, you have to go up to 16 digit. Okay, I stop it right there, right here, and I can, the number here we count is top to bottom. Okay, 0 1 0 0 0 1 0 0. You can go forever like this, depending on the machine they are asking for. They will require in the question how many digits they want after decimal point. And that is about converting from decimal to binary. Now let's see what else we can do. We can also see octal, base octal. Here what we're gonna see is how to convert a number from octal to decimal. Okay, I get rid of all these things. Octal to decimal. Okay, octal to decimal. Let's look at the number. Like let's say, for example, if you see a number like this, 296, let's say 296 base 8, you have to know this one is wrong, because as I said before in the beginning, whenever we have decimal mean what? The base is 10. So the maximum number we can have is 1 less than that. Like 9 is the maximum number we can have in a decimal number. And for binary number, base is 2. So 1 less than binary is 1. 1 is the maximum. 0 and 1 other number we can have. And for octal, here we cannot have 9 or 8 even, because octal mean we had to have 1 less than 8, that is 7. So 0 to 7, between 0 to 7 are the numbers we can have. So we cannot have a number like 9 in this case. So if you see a octal number given like this, it's wrong, because we cannot have a number above 8. So this one is wrong. So I give another number, like let's say we have 216 octal number, and we want to convert this one into a decimal number. Now let's see how to do that. First of all, we have to know that the first one always take the power of 0 is whatever the base we have. Here we have a base 8, so it's going to take the power of base 8 power 0, that is 1. And this going to take the place of 8 power 1, that is 8. And this going to take the place of 8 power 2, that is 64. Now we just have to simply multiply the position places. So first we have 64 times 2, 62 taking the place of 64. 64 times 2 plus 8 times 1 plus 1 times 6. So if we multiply this one, 128 plus 8 plus 6. 128 plus 8, that is 136. 136 plus 6, that is 142. 142 is the number we are going to have here. And that is about this. Now let's look at another one. Let's say we have some decimal point with the octal number with some decimal point. Let's say we have a number like 7.254, base is 8, and we want to convert this one into a decimal number. Again we do the same thing, like we have to know this one taking the place of 0, 8 power 0, that is 1, And what happens after the decimal fraction points? After fraction points, we had to know that it goes like -1. 8 power -1, that is 1/8. And this one is 8 power -2, that is 1/64. And this one is 8 power -3, that is 1/512. 512. Now let's do the same thing as we did before. 7 taking the place of 8 power 0, that's 1. 7 times 1 plus this 2 taking the place of 8 power -1, that is 1/8. So 1/8 times 2 plus 1/64 times 5 plus 1/512 times 512 times 4. Okay, now let's go and add them together. 7 multiplied by 1, 7, and then plus 2/8, that is 1/4, 5/64, and then we have 4/512. 4/512 mean 256, and then 256 divided by 2, that is 1. Okay, whatever, you can just plug it in the calculator and find it easily. So I just keep it as a whole number, 4/512. And when you plug all this number in calculator, you will get 7.3359375, and that's gonna be our decimal number. Okay, that's how we convert a number from octal to decimal. Now let's say in case we have a question asking how to convert a number from octal to binary. If we want to convert a number from octal to binary, what should we do? Octal to binary, we don't know that. We know how to convert from octal to decimal, but we don't know how to convert from octal to binary. But here what we can do is, I get rid of these things. Okay, here what we can do is, we can go in a long way and do that. Octal to binary, how to do that? We know how to convert from octal to decimal, right? So we can do that first. We can do that for octal to decimal first. And then we can convert from decimal to binary. That's how we can convert. Now let's look at an example. Let's say we have 216 base 8. I have done this one in my previous slide, like I did this before and erased it, and we found out the base is, like the number is 142 base 10. Now we want to convert this one into a binary number. To do that, again we divide this one by 2 until we get 0. 142 divided by 2. I write it in a place where I can go longer, so I'm gonna start over here. 142 divided by 2 is gonna give us 71, and the remainder is 0. And then 71 divided by 2, we are going to get 35, and the remainder of 1. 35 divided by 2, we are going to get 17, and the remainder of 1. 17 divided by 2, we are going to get 8, and the remainder of 1. 8 divided by 2, we are going to get 4, and the remainder is 0. And then 4 divided by 2, we are going to get 2, and the remainder is 0. Then 2 divided by 2, we are going to get 1, and the remainder is 0. 1 divided by 2, we will get 0, and the remainder is 1. Once we get 0 here, we stop it right there, go from bottom to top. bottom to top, that is 1 0 0 0 1 1 1 0, and that's the conversion of this given octal number to binary. I hope you guys find this video helpful. I'm gonna do more number system on my upcoming videos, and don't forget to subscribe my channel. See you guys later.